Everybody, just want to welcome you to Week 8, Module 8 for ME14, Mechanics of Solids course. So within this module here, we're going to take a look at a couple different topics. So we're going to begin Chapter 6 in our textbook. We're going to look at the stress in beams, talk about the longitudinal shear on a beam element of arbitrary shape, then get into some discussion on shearing stresses in thin-walled members, then moving on to look at some plastic deformations and talk about some unsymmetric loading of thin-walled members and shear center. So a couple bookkeeping items. Reminder, we have quiz number 8, and this will be due on Friday the 26th by 4 p.m. And also a reminder that at the end of the day, Monday, your homework number 3 will be due by the end of that day. Now, a reminder as always, I do have office hours scheduled from 9:30 a.m. till 10:30 a.m. on Wednesdays. Now, if you're unable to make it during these times, just send me an email, a message, or a chat on Teams, and we'll find a time that works for both of us. So as we begin our Module 8, this relates back to Chapter 6 in our textbook, where we're discussing shearing stresses in beams and thin-walled members. Now, in previous chapters, we'd considered normal stress due to bending moment for the design of beams. Now, as we continue on with this chapter, we're going to now also consider a shearing stress due to the transverse shear, in particular in the design of short and stubby beams. We're also going to take a look at longitudinal shear and analyze the effects of transverse loadings. So within this module, we have a couple different objectives. We're going to learn how to demonstrate the transverse loads on a beam and generate shearing stresses. We're going to determine the stresses and shear flow on horizontal section and beam. Then we're going to talk about determining the shearing stress in a thin-walled beam, moving on to plastic deformations due to shear stress. And then we're going to recognize cases of symmetric and unsymmetric loading. And last, we're going to take a look at shear flow and determine the location of shear center for unsymmetric beams. So again, relating back to your textbook, this is Chapter 6. So we break this into two different sections within the module. Module 8.1 is going to look at Chapter 6, Sections 1 and 2. And Module 8.2 is going to look at Chapter 6, Sections 3 through 6. So as we move on to Module 8.1, the first section for Module 8, we're going to take a look at horizontal shearing stresses in beams and the distribution of stresses in a narrow rectangular beam right there. So objectives within this. So as we just mentioned, we take a look at first the shear on the horizontal face of a beam element, then move on to talking about shearing stresses in a beam, and then shearing stresses in common beam types. We'll look at what these common beam types are that we're going to be using and seeing in different problems. And then last, we're going to take a look at and discuss the distribution of stresses in a narrow rectangular beam. So within this module here, we're going to go over some of the key theory, talk about the governing equations, go through some practical applications, and then do out some actual problems. So moving on to our second section here, Module 8.2. What we're going to do within 8.2 is we're going to take a look at a longitudinal shear on a beam element of an arbitrary shape, discuss the shearing stresses in thin-walled members, talk about plastic deformations, and then look at unsymmetric loading of thin-walled members and shear center. So again, within this here, still going to go over the key theory for all those topics there, talk about what governing equations we can use, go through some practical applications where we can apply that theory and key equations, and then actually do out a few problems.